Hello, and welcome to the series of System Design for Parallel Programming. So, in this lecture, we are going to cover the challenges which arises during the parallel programming. So, as with any other system, you get the challenges and the pitfalls to design and the burden to the programmer. The same applies to the parallel programming as well. Despite all of its benefits, there are the challenges which must needs to be addressed in the programming. So let's discuss that what could be the few most occurring challenges which you may need to handle during your parallel program. So first challenge is what you may consider is a deadlock. It is very important concept. So first of all, when the deadlock arises, okay. So consider when two or more threads are waiting indefinitely for each other to release the resources. So you have a say T1 and T2. So T1 demands that I can continue the execution only if T2 frees up the resources it is holding. Vice versa, T2 also comes and demands the same, that it requires the resource from the T1, and until the resource freed up, T2 cannot continue the execution. Both the threads are interdependent on each other. So it's not just that it can happen only with the two threads, but it can happen with the more threads. Like if you introduce a three threads, say T1 depending on T2, depending on T3, depending on T1. So there is a deadlock. So now what can be done here in this kind of scenarios? So how you can mitigate? So we need to design a resource acquisition order very wisely. And we need to consider that we have to use a timeout mechanism or a deadlock detection. So if your thread is waiting indefinitely, then it should not happen. So you can have a timeout or you can have a deadlock detection algorithms. So either of the deployment, it can help you and you can wisely allocate the resource acquisition. So this is one of the concepts that the next issue, what may arise in the parallel program, is the race condition. This is the one of the fundamental error which may arise with the accuracy of your system. So that's why it's very important to pay attention to the risk condition. So how this happens? So it occurs when the outcome depends on the unpredictable order of a thread execution and potentially corrupting the shared data. So what may happen that you might be expecting that you are running thread one, and after thread run, you will also have a thread two. Now, what may happen that you may have not considered the semaphores correctly or a logging mechanism. So eventually what would happen that your thread one has written back, say for example, some result and this memory block. However, unexpectedly, the thread 2 also comes and tries and write back to the same memory with its own value. Said this one. So what has happened is that for this particular memory region, your data has been corrupted. It was a shared memory. Now, this corruption of a data may lead to the inaccurate result when you write in your parallel program. So in this case, You can only mitigate this risk condition by implementing a robust synchronization and atomic operations, such as the synchronization process that we discussed in the previous module session. So let's go to the what would be the next condition which we may have to deal with. So this conditions, you can say it's a load balancing. So what happens that overloading some processors while leaving others idle can severely hamper the performance. So you have a system where you have multiple cores. Now, what may happen is that you may end up running a more number of threads, processes in few cores only. So you can say this T1, T2, T3, T4, T5, T6, T7. So if you notice in this kind of a resource allocation, your one of the core is staying idle, and this would stay idle for most of the time. So you can say it's a mostly idle, and this core is idle. So this happens with the lack of a load balance. So how we can mitigate is that we can introduce dynamic scheduling. Dynamic scheduling is a process through which we can avoid this load balancing problem. And we can partition the task such that the load is distributed evenly among available processing units. The next issue which occurs is with respect to the scalability. So, in the scalability, this issue occurs when a solution which works very well on the few cores, it may not effectively scale. So, you may see that your program is running as expected with the two cores. But when you're trying to scale up, so you are telling that instead of having a two cores, now you are having a 20 system of a two cores. However, you will anticipate that you may get a speed of a 20 as you are running a 20 nodes. But let's say you are not getting a 20 times performance. You are getting only the 10 times or a 5 times. So that means that a program is not a scalable. It is not efficiently scaled up. So what could be the mitigation process for this issue? That as a programmer, we need to design algorithms and systems with scale in the mind. We need to anticipate the growth, and it is a must need requirement. So, in terms of workforce and in terms of available resources, we have to take the scalability into the account from the very beginning. Now, what were the other issues which you may see with the parallel programming is that debug. You can say it's debugging or try. So, unlike the usual single core performance, okay, finding the bugs in the parallel system is not obviously challenging. Why? Because issue may only arise under the specific timing condition. You may not see the issue always reproducible. It is happening at a particular conditions. Let's say it could be because a core has been heavily loaded or some data corruption or any of the issues that we have discussed in this earlier challenges. So any of these cases, it is very, very difficult to handle the issue or triage the issues very quickly. So how we can actually mitigate this? How we can improvise our debugging process with the parallel programming? So we need to explore that we can utilize the specialized debugging tools which are made for the concurrent system and consider that we can determine these tools to facilitate the troubleshooting. Then only we can efficiently and effectively triage debugging in the parallel program. So when you look at all these challenges for the parallel programming, all these challenges require that we think about the design as early as possible and test rigorously to ensure that our systems are robust and efficient. Then and only then we can effectively data parallel program, which is usable and most profitable.